Yeah, I don't know if everyone is back, but just let me know if you can see my screen well in the presenters mode, or is
Yes,
it
it's good. It's good.
okay? Great. So yeah, let's start with this final session of the summer school. Um, I know that you have had already some sessions on decision making. I guess a couple yesterday, one practical one in the afternoon, and today two more. So the idea with this last one was to provide you like an example of a success story where the different concepts that have been explained by my colleagues at BSc especially. So Raul, in this practical session where you had to put yourself in the place of decision makers, and also the more methodological concepts that Dragana shared today into I would like to put them like into action here, so you can see how they apply in real life, although you will see that also we take a lot of assumptions in these examples. And yeah, let's try to start moving. Yeah. So yeah, I wanted just to start this presentation by introducing a bit myself, although you could have guessed it after Dragana's and Raul's presentation. So we are members at BSc of the group that we call Earth System Services. And in this group, there are a lot of different profiles. Many of them are natural scientists from different disciplines, of course, and some of them are working more on climate services, which is actually the topic I will talk the most in this presentation. But there are also other scientists working on air quality issues and health, global health resilience issues. And specifically, Dragana and myself are leading together the knowledge integration team. And here, as Dragana was saying, we believe that interdisciplinarity is very important. And that's why we have people coming from different fields, from social sciences like Dragana, communication like myself, and we have also other disciplines like user experience, environmental economics, and even a journalist. So this is just for you to see how all these profiles can complement each other. And the main objective of our research is actually to close this gap between science and society. And in order to illustrate how we do it, I'm going to use this graph that you can see at the bottom of the slide from Vogel et al. And actually, in this graph, you can see like different steps that are not meant to be linear, but there are different stages that need to happen for climate data to reach users, let's say. And they can be like linear, but then iterative as well. So the things that you learn in one stage can inform the next stage and can inform the previous stage. So it's all the time taking into account the feedback from users. And the main idea that I want to convey here is that different steps need to be made to transform data to information, and then to transform this information to tailored information that informs decisions. So it's not immediate. You cannot just use the data as it is and then expect the users to do something with it. So the first stage would be this generate. And by that, we mean generate information and knowledge. So we learn normally in climate services, what we do is that we learn from the past, what happened in terms of climate conditions. Then we monitor the climate conditions of the present date, and we try to forecast the future as well to give some alerts or to advise the different sectors and the society in general. Then there is another stage, which is translate. And here what we do is to translate this climate data and knowledge into information, as I was telling you, that is relevant for different sectors. It can be agriculture, it can be health, or other sectors. Then there is another stage, which is transfer, but we don't like that much to use the word transfer because it conveys this notion of linearity. So you produce something and someone else uses it. But in the research that we are doing, we try to integrate different knowledges because we depart from the assumption that everyone is an expert in their own field. So users also are experts in what they are doing. So we try to put these two sources of knowledge together and integrate and make them match. And then there is another stage, which is actually using this information. So integrating the climate information in the decision-making context of the users, and so that they can use to take these decisions, also to develop policies or even plan for longer term. And then in this process, we can also learn what works and what is not working, and we need to adjust and change it either in this stage or in previous stages. And then as I said at the beginning, I will use a success story, and the success story will be one of the climate services that we develop for agriculture in the framework of this project that you see here, the MedGoal project. This is a project that finished last month after 4 years and a half of work. And the main objective of this project was to make European agriculture and food systems more resilient, sustainable, and efficient in the face of climate change. And what we did was to develop a proof of concept of climate services, so something that was not an operational service, but that is, let's say, stopped one step before, and it was enough to demonstrate that an operational service could work. And in the project, 3 different users were involved, representing 3 Mediterranean food systems. There was a user from a winery, so representing the grape and wine sector, another user who represented the olive and olive oil sector, and a third user who represented the durum wheat and pasta sector. And these users were actually partners in the project. So it was not someone we were reaching out for some specific questions or doubts. No. They were one more partner. They were attending all the meetings of the project. They had the same capacity as technical partners to take decisions, everything. So they felt more or less compelled to deliver as well and to participate in all the activities. And the project tried to identify which were the key decisions that these users need to take, and then to be able to generate the information for these decisions. In this presentation, I will mostly focus on the MedGoal dashboard, which was for the grape and wine sector. However, we have been working in other services as well. But the difference is that the MedGoal dashboard was entirely developed in the MedGoal project, whereas the other 2 services were services that the companies were already using. So they had these decision-making tools in-house. And what MedGoal was trying to do is to provide additional information at longer time scales to be integrated in this decision-making workflow that users were already using. So the project was trying to show that climate services can be used in a different way, either as standalone tools or integrated in other pieces of information that users already have. And here you will see a graph that is very similar to the graph that Dragana showed previously, the one where you could see the different stages of co-production of climate services. And she was showing you that you had a potential user and then a user once the user is engaged, and then once the user is involved, you have a champion user. So here it's more or less the same concept, but I adapted it for the case of the development of the climate service in MedGoal. So you can see that in the stage of awareness raising, the project was using communication materials that were specifically designed to engage with users and also the current communication channels. Then for the stage of knowledge exchange, where users are involved, we were using workshops, focus groups, and also these user-provider discussions. And these discussions were more internal, where project partners used to discuss. And then there was a stage of co-development of the climate service, where we had different activities. One was a functional specifications document. So it was a document built together with the user, the wine sector user, and the other technical partners in the project, where the minimum, let's say, requirements that the service should have were specified and discussed. Then after that, we had also these dashboard sprints. And here, these were regular meetings that took place approximately every 2 weeks, where every time a new development was done to the dashboard was the main tool that we were developing, this development was discussed among the different partners. So everyone could say, this is not clear, or I don't like this, or I feel that this feature is missing. Then we had also validation meetings. This means that the user involved in the project was also meeting with colleagues inside the company, but also outside the company, so other users in the wine sector. And he was showing them the dashboard for them to provide some feedback to the tool. So in this way, you make sure that also users that were not involved in the development of the climate service can understand it, or or can highlight things that need improvement. And finally, there was a co-evaluation stage as well, where we tried to identify which were the benefits that the climate service tool that we developed could bring to these different businesses that were producing wine or grapes. So, and now, because I presented you at the beginning of the talk, this framework that we are following, I will provide you like some details just for you to have a flavor of things that are important to take into account in each of these stages. Of course, there are many other issues, but because I will not have time to go through all of them in this presentation, I have just selected some points that I think could be interesting for you to see. So in terms of generating, it's important to start identifying which are the needs of the sector for which you want to provide a service. Of course, you normally the climate science community can generate predictions, future predictions of environmental climate variables like temperature, precipitation, wind, and so on. But sometimes this is very general data that can be useful to some users, but sometimes it's that general that it's difficult that they can see, how this data translates to something that can advise their decisions. So a first step is try to see which are the decisions that they need to take, and then try to identify how the type of information that the climate community is able to provide can fit in here. So for instance, we know that climate scientists can provide forecasts about weather. So for the next 1 to 15 days, we know that also we can provide climate predictions at subseasonal, seasonal, or decadal scales, and also longer term climate change projections. So then what we try to do in this graph that Raul showed it to you yesterday already is the different decisions that users take, how they fit in these different time horizons, let's say. So here you can see them. For instance, you can see that when it comes to deciding the seating, the choice of variety and rootstock, this is a decision that is taking in the long term. But whereas there are other decisions like deciding if you spray against pathogen pressure, it's taken in the short term. So this was useful for us. And then the project decided to focus on two different timescales. One was the seasonal forecast. And for this, here, the decisions that are in darker colors are the ones that we tackled in the project, not all of them, of course. And then we also focus on the long-term scale. And these are the two decisions also that we focused on. And then when we started discussing with the users, we realized that there are a lot of concepts that, although the scientific community takes for granted, for users are very alien. They are not familiar with many concepts. And one of these concepts was, for example, which is the difference among the different type of predictions and temporal scales. Normally, if you tell users that you can provide a forecast for the next months or the next years, they tend to assume that it will look like the weather forecast. So this was something that we discovered at the beginning of the project, that users were expecting a product that was very similar. And then we had to work on all these info sheets, all this communication material that explained which were the main differences, how they would be able to apply this information to their decision making. We were providing also examples. And what is important is that we were preparing this dissemination material together with the user involved in the project. So we made sure that the jargon that the user was using was reflected here and not the jargon of the scientific community. These are important details that when it comes to communicating can make your work much easier. And then we also put special attention in differentiating. So for instance, we were telling users, okay, when you have a weather forecast, you have, for instance, the temperature in Porto in the next days in absolute values. We can tell you, okay, you will have 20 degrees tomorrow. But when it comes to climate predictions, you get another type of information. And an example of that can be that you will know the most likely category for next spring temperature in Porto in relative values, which means we will be able to tell you if the temperature will be normal, below normal, or above normal. And then users start to see which is the difference and which is the potentiality of these predictions. Perhaps they can realize if this is useful for them or not that useful because they need a value. And then also we did the same with climate change projections, that we were telling them that they could see the change in temperature that they should expect at the end of the century, for instance. Then also we took care of explaining to the users how a seasonal climate prediction looks like. And here is one of the examples that we discussed with them in the project. So here you have a seasonal prediction of temperature for May 2016, and for this particular location in the south of Spain. So we were telling them that normally in this map, what we display is the most likely tercile. In this case, there was a 52% probability that the temperature this year and this month was above normal, but that they should take into account that there is also probability for the other two categories to happen. So if the temperature turns out not to be above normal, is not because the prediction is wrong, but it's because it was not predicted as the higher probability. So these kind of things are important to discuss with users. And then we also try to understand which are the barriers for the uptake of this information by users, because several research studies tells us that even if the science is advancing and we are more confident on the results we are providing on this type of predictions, there is still some resistance from users to take them on board. So we know that there are lots of uncertainties related to climate data, and these are not covered in these two examples that I'm showing here. But the main ones that we discuss with users are these two. The first one about the decision uncertainty. If you tell them that there is a 52% probability of temperature to be above normal, okay, even though they know the decision that perhaps this could trigger, they don't know if taking the decision or not, because it's not a high probability. So for them, perhaps they need to be more sure about this possibility of temperature being high. And we were discussing with them, okay, which is the probability threshold that you need to know to take a decision? And this is actually not clear. So what we tried to do in this study, for instance, was to look at the frequency of probability. So when you have a probability in terciles, we were looking, this is for wind only, so it's not temperature, sorry, because I didn't have it for temperature to put here. But for wind, we were looking at the frequency of prediction of the most likely tercile in terms of probability. So when you have the most likely tercile, which is the probability that you predict all around the world, well, in different locations around the world for wind. And we could see that normally the most likely tercile is between 30% probability and 60% probability. And only in 23% of the cases, you have a most likely tercile with a probability of more than 60%. So for users, this is a bit striking because they don't know what to do then. And also there is another type of uncertainty, which is related also to the quality of the forecast. So we used as climate scientists, you know that there are certain regions of the world where you can predict better because you have more skill. And then this here, for instance, you can see a map of skill where the regions that are in blue means that the quality of the forecast is not good enough, let's say, for decision making, or it's not better than climatology. And the regions in red are the ones in which the prediction is better than climatology. So this for users is something that they don't sometimes they don't understand completely, or when they understand it, they think that climate predictions are not that useful. So, and here is when we go to the second stage, which is translate. We need to translate this information to terms that show to the users that in certain occasions, they can find value in these predictions and they can use them for making decisions. And actually, when talking about translating, yeah, I like to show you this word cloud that comes from a workshop that we organized with climate service providers. So many people involved in climate service projects that were trying to discuss with users and to co-design climate services for decision making for someone. I mean, each service was targeting a different user community. But during this session, we asked them which are the concepts and which are the terms that are more frequently used in this field, and that when you talk to users, they don't understand. And as you can see, skill was like the winner that day, but also other concepts like uncertainty, anomalies, percentiles, ensembles, or even model, which is something that we could think is very basic. Sometimes they don't know what you mean by this. So one of the actions that we decided to do to try to translate the concept of skill was to develop an application that I would like to show to you here, which was called the Weather Roulette. This application was developed under a project that was called Euphorias that ended some years ago already, but then we recovered it for the S2S4E project, which was more recent. And in both projects, we were engaging with the wind energy community. So it's a little bit different from MedGo, but it's just to exemplify here this tool. So we conceived this weather roulette application as a communication and engagement tool that allows us to show to the users the potential benefits that they can have using climate predictions. And we were doing this comparing climate predictions versus using the climatology in the long term. And you will see that this in the long term is really key here, because if you just have a look at the prediction of 1 year, sometimes users can lose trust in the predictions, but this is something that requires having this long view. This weather roulette approach is nothing that we have developed or invented. It's based on an approach that existed already from this paper of Hagedorn and Smith. We have just adapted it for our purposes and also developed the application. And if you are interested, you can access this link, and you will see it's a very intuitive and easy, let's say, game. And more than a game, I say it's a game because it's learning by doing, but in the end, it's more as a demonstration of the value of climate predictions. So yeah, so what we have is that once you access the application will translate climate data into economic value. This is the main idea. And you have like two playing options when you access the application. Option one is that you use the climate predictions to take your decision. And option two is that you use the climatology. Of course, this is an oversimplification. This is not how users take decisions, but it's just to illustrate this concept. And in terms of climate predictions, what we use is the calibrated ECMWF system 4, because it was developed a long time ago. So we haven't updated now with the new predictions, but I think it works likewise for illustrating this. And then for the climatology, we were using the historical wind speed observations. And then apart from these two options, we have a betting scheme also that works in the following way. So first, with the climate predictions, you start with a prediction for 1 year, one particular year, and the player has 10 euros. And these 10 euros get distributed. This climate prediction is in terciles, as you can see, and it gives the probability of each of these three categories to occur. And then these 10 euros that you have at the beginning, the player distributes them according to the predicted probabilities for each of the categories. So in this case, 2.9 euros will go to the green category, 4.9 to the gray category, and 2.2 to the blue one. And then the player plays the game, and here, as you can see, this triangle indicates the category of the observation. So in this case, what happened is that for this particular GRT, we got that the green category occurred. So the money that the player has bet in this category is multiplied by 3 because it's the number of categories that we have. And then this is the money that the player has at the end of the first round of the first year. So the player lost a little bit of money because the bet was not for the, so the prediction told us that the category with a higher likelihood was the gray one, and it didn't occur. And then for the next,
Marta, we have a question. What does it mean to translate climate data to economic value? I don't know if you want to elaborate on that a little bit.
Okay. So it's what does it mean to translate it? Okay, so it's a little bit what I'm explaining now here. So instead of, you will see at the end of this part, but instead of telling the users, this prediction that I'm giving to you has a skill, so it has enough quality for decision making, and giving them a value of skill, telling them the skill is 0.3, imagine, because when the skill is positive, you normally assume that the prediction is better than the climatology, so that it has another value. Instead of telling them this, we tell them, okay, if you were using this prediction instead of the climatology, and you I don't know, let's take this example, and you had 10 euros at the beginning, and you compare what you can win with one or the other, you would have benefits. So we translate the 0.3 to an economic value. It's not true because this is an assumption. As you see, it's an oversimplification. So the ideal case would be to use real values that the users are risking, that they have to invest, and then that they lose or they win. But because this was just a framework, I'm just guessing all the numbers. But the idea is translating a skill to money, let's say. I hope this is clear. Perhaps when I finish this, you will see it better as well. Okay, so then, yeah, this was for the year one. If we go then to year two, we can see that the same logics apply. You start with 8.7 euros, and then you distribute this money among the three predicted categories. You see now the prediction for year two is different. You have 84% in the blue category, 4% in the green, 12% in the gray. And then you distribute accordingly, and this triangle tells you that what actually occurred was the category that you predicted, in this case, with the highest probability. So you multiply now the 7.3 euros that you invested here in this category, that you, bet in this category per 3, and you get, in this case now, 21.9 euros, and so on. And you continue doing the same for consecutive years. This is for the climate predictions, but for the climatology, because we assume that the same probability is attached to each of the categories, it doesn't matter. You always will finish with the same amount of money that you started with. So if you start with 10 euros, you finish with 10 euros. And in the application, these two calculations, the one for climate predictions and the one for climatology, allows us to, at the end of the game, compare the benefits that you get and see if it would have been better to use the climate prediction or the climatology. Of course, this is for a generic prediction, for a generic decision that we don't know. As I told you, it's not realistic, it's just to compare. And how we can play this game. So you have two possibilities when you enter the application. The first one is to play for 1 year only. You can choose. And the second one is to use for 33 years. And this means that automatically the application calculates the benefits or losses for the 33 years. And the years we have are a bit updated, but yeah, anyway, it's just for illustration, and 1981 to 2013. So if we decide to play just for 1 year, you select it and you see this map. This map is a map of skill. And in this case, we use this index. There are different indices. There are different metrics to calculate the skill. But this one is the ignorance score. That is the one that Hagedorn and Smith were proposing in the weather roulette. I don't know if there is a...
Oh, just a comment for me.
Okay, we can go through it then later. Yeah. So this is it, and in the map you can see that the blue areas, as I explained before, are the ones without skill. Then the white ones with 0 skill, which is no skill as well, and then the red areas are the ones with skill. So the player can choose 1 pixel. You can click, and then you go to the next screen, where you can select the year you want to play. This is the first year, but then you can change it, and you see the skill of the prediction for that year. So this prediction has a skill in this case, and it tells you that the probability to be above normal is 29%, the normal category 49%, and the below normal category 21%. And then you can decide if you want to play with the climate prediction that we call resilience here, or with the climatology. Then you play, and you see that in this case, the climate prediction was telling you that well, let's start by the observation, if you want. Like the observation was the above normal category, so the green one was what happened in reality. But the climate prediction predicted this category with a 29% probability, and the climatology, as always, with a 33%. So what happens that if you play with the climate prediction, you lose the game, let's say, because the climatology in this case would have provided a better prediction. Because, you know, if you take into account the betting scheme that I explained before, you would have bet more money in the in this category by using climatology. Then what I want to convey here is that, okay, you lose with this first year, but then you can continue playing for individual years, and then you play for the second year, and you see that you win in this case if you use the prediction. You play again for another year and you win, and another year and you lose, and another year and you win, and so on. And all this is to show you that if you play with the weather roulette for individual years, anything can happen, you know, and you can have return ratios which are above 1 or below 1 independently of the year. So there is no rule, and that's why many times users don't trust these predictions if they only see the outcomes for a particular year, and this can help them to see the uncertainty in these climate predictions. But things change when you go to several years. If we play the weather roulette for all the years that we have, and then here you can see this is a region where we have skill, not a lot, but 0.18, so it's above 0. And we play, as you can see, we play now with the application, and it runs the weather roulette from 1981 to 2013. And what we get is that you win. And we thought this is very illustrative, because even if you have years where you win and other years where you lose, some years the climatology performs better, some other years not. In the long term, if you have a skill in your region, you should have benefits. You should have this return on investment as a positive value. And this is this is actually related to the question that I had before, that how do you translate, what do you mean when you translate, by translating it to economic value? This is what I mean. If we invest 10 euros at the beginning and we reinvest them according to the predicted probabilities for 33 years, this would be the return that you get. This return on investment is calculated by the capital that you have at the end minus the capital that you had at the beginning divided by the capital that you had at the beginning. So it gives you an idea. And then the same concept, if you play with a region that has no skill, that has a negative skill, and then of course, here again, you can have years where you win and years where you lose. It depends, it will depend. But in the end, when you play it for enough years, you will see that you lose. And it's the climatology who wins. So it's better to use the climatology, so what happened in the last years, than to use the climate prediction. And I think it's very illustrative for users to see that if you give them predictions that have skill, they should be more or less confident. This is all in ideal terms, of course. Then you need to discuss with the users what we were discussing yesterday. If they are more risk averse, if they have more to lose or to win, and then you will need to adapt it. But it's a way at least to convey the concept of skill in a way that it's not using a climate science, a measure used by the climate science community only. Then if we move to the third stage, it's about integrating. And here what I wanted to show you is that sometimes when we share the information with users, we have all these maps and graphs that have a lot of information. They are very comprehensive. And sometimes the users need less information. We tend to forget about it because we calculate lots of indices and because we, as climate scientists, are very conscious of uncertainty. They want to be very transparent all the time, of course, and show everything. But sometimes this can be counterintuitive if the user needs to take a decision, because taking a decision, when you talk to them, it's like, tell me if yes or not, because I have to, to decide, and I cannot process a lot of information. And then in this publication that we did, we were trying to show how sometimes it's just a matter of visualizing things in an easiest way. And this is what makes the difference among users understanding your visualization and using it, so using the climate data that you provide to them or not. And here I just wanted you to have a look at these two visualizations. The one on the left is the previous one that we had from a long time ago, and the one on the right is the redesign. And as you can see, this is for wind speed as well. As you can see, the intensity of wind in the former visualization, it was represented with a lot of categories, a lot of lines with different that they were wide or narrow, and this was very difficult to see on the screen. So then with the redesign, we were discussing with users, and normally users want to see the predictions above or below a threshold. If they are interested in wind speeds higher than, I'm inventing it, 40 meters per second, so they will just move this slider and they appear on the screen. So they are not interested in everything, and even if you give them all the information, sometimes it's difficult to understand and even to see in the screen. So it's a way to simplify things. And the same for the predicted change. So we had 5 categories of predicted change. We were telling users the predicted wind speed will be normal, or a little bit upper than normal, or much upper than normal. And finally, we realized that they were only interested in 2 categories, so upper than normal and lower than normal. And that's why we were representing these categories here into very alive colors, if you may, like this yellow and this blue. And then the situation for which they were not concerned, it's more closer to the background. So these are strategies to reduce the cognitive load of users, so the effort they need to make to find the information they need for their decision. And in the end, this always means that they will be more ready to use a climate service than if they are lost in in what everything means. And now if we move to the case of the MedGold dashboard, this is what we provided to users in MedGold. And well, here it's just to show you that this looks different from what I show you, because this is tailored to users in the agriculture sector. This dashboard was for the wine users, and they could find here information on 3 different timescales: historical climate, seasonal forecast, and long-term predictions. And here you can see how the different information that you could find select from. So they could access to different types of information: climate data, bioclimatic indicators, or wine risk indicators that I will explain you in the next slide. And then also the region of interest, and the year, the month of interest, and download this data. And you can, this is the URL where you can find this climate service, although you need to register to use it. This is, I was telling you that this dashboard have different types of information, and this is because of what I was mentioning at the beginning. You need to tailor the information to the decision that needs to be advised. And that's why we provide the essential climate variables, temperature and rainfall, but also some tailored indicators for this sector. So we have defined these indicators together with the wine users, and these are relevant parameters that they need for their decision making, like the spring that falls, the rainfall, that falls in spring, the number of growing degree days, which also relates to some decisions they need to take, and so on. And then we have even a higher level of complexity, which is made from the combination of different climate indicators. In the project, 2 of these risk indices were developed for the wine sector, and these are the heat-related risk index and sanitary risk index. This is just for you to know how you need to aggregate and tailor this information to be useful, what I was saying at the beginning. Yeah, I will skip this part, but because I would like to focus more on how we can explain to users why they should be using the climate service that we provide. What other value can it provide to them? And we did it by developing one of these user guides that are very common. But in the user guide, we not only show them the different functionalities of the tool, but also some applications, some use cases in which they could take a decision. And we are able to do this because the users are involved in the project, of course, and we know them. So the use case number 1, in which we wanted to illustrate the use of long-term projections, was this one. Your wine company is concerned about the impact that climate change will have on your top-selling iconic wine. The grape variety used has an optimal growth between 16 and 19 degrees. If your vineyard sees higher temperatures in the future, you will need to look for alternative sites to maintain your production. And then the question that the user may have is the quality of my iconic wine threatened by future climate change? So this was a situation that the wine sector user tell us he would face. And then we show them in the guide what they would be doing to solve this question. So they select the bioclimatic indicator. In this case, the growing season temperature is an indicator that tells them if this range in which their grapes can grow is still viable. And they choose, in this case, for instance, this time range and the intermediate greenhouse gas emission. And here the user can see that in this time period, the temperature in his region of interest is expected to be above 20 degrees Celsius, which is actually outside from the range of the grape variety that he's growing. And then we did the same for climate, for seasonal forecasts. But I will skip it as well, because here I would like to give you, before closing, just a flavor of a use of this type of predictions. And for you to see the application, this is one common doubt that the user involved in MedGold, in the MedGold project, had. And it was that one situation that affected the production of grape and wine the most was when he had springs with a lot of rain and with warm temperatures, because this favors the risk of fungal diseases. As you can see here in this image, when there is this downy mildew fungi, it has impacts on the yield. So there is a loss of yield, and the producer needs to buy plant protection products and needs to contract extra labor. And also there is difficulties for machinery to enter the field because it's very wet. So the two decisions that the wine producer needs to make is, do I need people to manage the canopy? So do I need to apply canopy management and cutting some leaf to favor aeration? And the second one is, do I need to spray some plant protection products? And normally the business strategy of the user involved in the project, of course, this is very user specific and you can never generalize, is that they apply always the same strategy independently of the climate conditions. In January, they tell the purchasing department to order a stock of plant protection products and to contract the labor for the season. And then this means that they always apply the scenario that the rain in spring will be normal, okay? And even if the observation turns out to be above normal or below normal, they do the same. They invest the same amount of money per hectare in plant protection products and the same amount of money in canopy management. But then, of course, if the season turns out to be very wet, because they plan for a normal season, then of course they haven't spent enough on plant protection products and canopy management, and this it's reflected in some yield losses. Of course, these numbers are very general and are averages, and potentially there will be other factors affecting. It's as before. This is an illustrative exercise only. And then, if the season turns out to be drier than normal, even though he has spent the same and they have the same revenues in terms of yield as well, there is a waste of plant protection products because they would have spent more than they would have needed. And in the end, this is something that is lost because the validity of these products normally is of 12 months. So they cannot reuse them in the next season if they have overspent. And then what we try to do in this study led by Ilaria Vigo, that she's an environmental economist in our group, is to compare the value of the decisions taken with a climate service or without the climate service, as they are doing now. And then we were trying to make some calculations. These are also assumptions. And in this gray part of the table is what I have explained to you. So it's the business as usual, assuming that the season will be normal. But then if the producer is using the climate prediction, perhaps if the prediction tells you that you will have above normal rain, then the user may change the decision strategy, and the same if below normal rain is predicted. So the main things that we can see here is that although if the user gets a prediction that the spring will be wetter than normal, probably they will spend more money on plant protection products and canopy management. But in the end, there is no difference. So I mean, if they acquire a lot of products and it rains a lot, it's fine, they are safe. But if not, because they acquire them anyway, they have some losses because they have spent products and contract people that they don't need. And then if we go to the best situation, the best situation possible is that the prediction gives you a below normal season, so less rain than normal, and it actually happens because then the wine producer doesn't spend a lot of money in plant protection products and canopy management, and the production is good, and this is reflected in savings and more sustainability because you don't spend more products that go and pollute the soil and the groundwater in the end. But you can have also other situations, which is the worst one, in which you predict a below normal rainy season and then it rains a lot. And then this is reflected in losses in yield, but also it can be that at the moment when you need the plant protection products, they are not available in the market because everyone is trying to buy some. So this is very general, of course, but it's just like for you to have an idea of the type of complexity that users need to manage. And yeah, this is just to summarize. Because I was telling you at the beginning that we would like to compare a decision made with the climatology or with the business as usual, which can be different from climatology, and a decision taken by using climate predictions. And here you can see that you win the most from climate predictions when there is when a rainy spring is predicted and it actually happens. If you are able to predict this, then when you compare to the losses you had using your business as usual, you see that the more benefits are in this range. But contrarily, if you look at the worst situations, it's when you predict a dry spring and then you get a wet spring and then you lose more money. And also the situation where you predict a dry spring and you get a normal spring, it's also a little bit damaging, not that much, but yes. And the best, and also a second best situation would be when there is a dry spring and you predicted it in advance, so you could save some money and it's good for the environment. Yeah, and well, and this is just, well, it's perhaps you can read this. It's just to summarize the presentation, because now I would like to listen for of your questions. Are there any?
Sorry, I'll start off quickly. Can you hear me? Thanks. I was just wondering about wording. You know, in IPCC, they are trying to avoid percentages and go with words, likely, more likely than not. You seem more on the percentages. I'm wondering, was that a conscious choice? And because actually words are very value laden, they can steer you in certain directions. You know, if you say something is, you know, the example I always give is if you had a 33% chance of your plane crashing, IPCC will call that unlikely, but most people would not use that as a description. So can you comment a little bit on that, on the terms of, you know, positive, negative, of valence and to risk and that sort of thing? Have you explored that?
We haven't explored that comparing like both approaches, but I would say that it always depends a lot from the user that you are discussing with. With this, I mean, if they know almost nothing about probabilities, for sure they would prefer to know to use this terminology from IPCC, which it has been also criticized as far as I know, because sometimes you say highly unlikely or you know, highly likely and so on, and sometimes it's also a little bit confusing. But yeah, it's more it's closer to the layman. This I agree. But then it depends a lot, because in the cases I was describing, these users were very technical. The ones in the energy sector, for instance, they were technicians working with wind energy, so they needed to know the probabilities in this case. And also the wine sector user, it was actually the same. He had also a PhD and so on, so he was very used in looking at numbers, so he needed the numbers. It's true that when we were talking with other users in the olive sector and in the durum wheat sector, it was totally different, and they would have preferred this other terminology that you are telling me. So my answer would be that you need to explore which is their background, and then try to discuss in the terms that they prefer.
Yeah, sorry. The other question I had quickly, since unless if someone else has a question, please jump in. Actually, Dragana pointed out that if people see climatology 33%, they actually don't tend to pay as much attention to the risk of high and low as they might otherwise. And so I wondered about that aspect, because it seems to me that skill is maybe not necessarily the most relevant thing. And if people are underestimating the risk because they're, and actually it may also be that the that the data isn't highly reliable. We think of some really rare events that are not represented in the record. So I mean, have you thought about that? Because climatology is not necessarily uninformative if people don't really understand what the risk is.
Yeah. We have thought about that, and actually, this was one of the main critics that we received when we try to publish all these approaches, where we are very generic and we try to compare things. They tell us, of course, but people don't use climatology many times. They have their own approaches. Also, so it's difficult, and also if you tell them, for instance, that there is a skill or not skill, they cannot compare to climatology if they use a different strategy. So yeah, we know, we are aware, and this is actually what we try to do now when we discuss with users. We try to understand their strategy. For instance, in the wine sector, I was telling you, they don't do anything. They don't, it's not that they look at the climatology or anything. They just have their way of doing things and they purchase the same, and that's it. So you need to understand this. And it's also very case specific. For some users, for instance, it's only like, okay, the only situation that damages me is when I have very extreme values of temperature. Other than that, I'm not interested in anything. So yeah, then you need to change this, and these examples that I have shown you don't apply. But it was just to convey the idea in this case.
Yeah.
But, yeah.
Okay, we have a question from Nella. Do you want to just I hope I said your name correctly. Do you want to ask it directly?
Yeah, sure. Yeah, this question came from, I think, the first example, or with a certain dashboard that you showed with the long-term planning use case in the wine sector. And I saw that on the dashboards, they could pick RCP scenario, which seems like a very heavy choice for a user to make. And I was wondering how this topic of like the socioeconomic or emission scenarios came up in all these discussions and different phases, and if this is a dashboard more for the user to see the impacts of the scenario, or are they expected to make a bet on the future? Or I'm just curious how this was discussed with them.
Actually, also deciding the scenarios was a little bit tricky because we didn't know which ones to show and which ones not. But then we went for this option that everybody is showing this intermediate and high impact scenario. And then when we were discussing with users, we were explaining them that these are possible situations of future walls, and that it can be any of those, or it can be a mixture of those. So it was not actually that, I must say that it was not that difficult as when we were trying to discuss seasonal forecast. For us, it was more challenging seasonal forecast because long-term scenarios, users are a little bit more familiar with them. This is what appears on TV nowadays. They tell us, okay, at the beginning of the century, we expect the heat waves to be that much acute and this kind of things. So more or less they knew. It's true that RCP, they didn't know what it meant. So in the discussions, we were trying to also to talk about that and to explain it in different words. Actually, in the dashboard, we try to put some help symbols where they can expand a little bit more on that. But it was not that challenging. And I think also the fact, this was also a critique that we had during the project, is that the fact that for seasonal predictions, we are displaying uncertainty. And for long-term climate change projections, we are not talking about uncertainty in the dashboard, although we all know there is much more uncertainty, make it for the users easier. The way we will try to explore this uncertainty from now on is try to use more this approach of storylines that can explain much more better than us. But we try to go for this approach, trying to picture like these different possibilities, because here you can see a couple of them, but nothing is changing, just the degrees of warming, and that's it. But perhaps explore how the world might look like under different scenarios, and also for something that is very tailored to the users, not only like as you see here, some of the variables, but also all the indices that we develop, also how they are going to change. So yeah. But yeah, I would say we succeed quite well with explaining this with the users, I think.
Thank you. It's very interesting.
Okay, thank you very much. We're right on time, I think. So can I please encourage everybody to come to the session in 2 hours' time, when we'll just take reflections, and I would like all the participants to also reflect, because we want to hear back from you. And I know this format is difficult in terms of getting feedback, but I'll encourage people to really speak openly. And so have a good break, and we'll see you back in 2 hours for the final session. And thanks, Dragana and Martha. That's great.